Okay, so today we're going to talk about complex fractions, and complex fractions are essentially rational expressions where you have a fraction and you have fractions within the fraction. So an example of a complex fraction could be something as simple as this: 1 over x, which is over y over z. Or it could be much more complex and have something like this: 1 over 2x plus 3 plus 5 over x all over 2 over xy. So complex fractions can be fairly simple or they can be complex, but what makes them complex fractions is the fact that there is a fraction, one or more fractions, within the original fraction. Okay, so of the methods that we use to simplify complex fractions, there's one method where you simplify the numerator and denominator as much as possible, and then you divide and simplify. What that means is, for instance, we might have an example like this. Where is it? I'm going to use this one. 4 over 2 plus x over y. Nothing to simplify in the numerator, but in the denominator I need an LCD. So my LCD is y, so I'm going to make this 4 over 2y plus x all over y. So to finish this problem off, we're just going to multiply. We're going to divide, but we're dividing by changing the division to multiplication and flipping that second fraction. So then we wind up with this, and we wind up with 4y over 2y plus x. Now, that's not the only way we can do this. We can also kind of eliminate the denominators in the beginning. And for this particular problem that we just did, it's not that big of a deal, but we could instead find the LCD of all fractions and multiply each term by it, and then simplify. The simplification is a lot easier. Again, for the example that we just did, it's not that big a deal because we have 4 over 2 plus x over y, and the LCD here, of course, is still y because 4 over 1, right? So the idea is we multiply every single term by y. So 4 times y is 4y, 2 times y is 2y, and y times x over y, well, the y's will cancel out and we'll just be left with x. So we wind up with the same answer, but with a lot less work. Okay, sometimes the problems are a little bit more complex. For example, we have 1 over xy minus 1 minus 1 over y squared all over 1 over x squared y minus 1 over xy squared. In this case, our LCD is more complicated. We need at least an x squared and at least a y squared, so that makes our LCD x squared y squared. But again, when we're multiplying, we're going to be canceling things out. So when we have x squared y squared times 1 over xy, we're going to be losing, right, if we do this, x squared, y squared, we're going to be losing the x in the denominator and the y in the denominator, right? And so, I don't need this right here. Let's get rid of that. And we're going to wind up with simply xy. When I multiply that here, and I multiply by x squared, y squared, the y squares drop out, and I'm going to be left with just x squared. Following the same pattern here, I'm going to have x squared, y squared, and I'm going to drop everything but an x, a y, a y, and then in this one, when I multiply by x squared, y squared, I'm dropping everything but an x. Now that looks like it's all the way simplified, but I'm noticing in the numerator that we have a common factor of x, so I can divide that out, and I get y minus x, and that's over y minus x. Those are exactly the same, and I can cancel, and I wind up with just x. So that's pretty much what we did today in class, and we'll be working on that some more on Tuesday and Wednesday, if you have class on Tuesday. All right, see ya.